Hello and welcome to Life at Pulse. This is lesson 4 on the chemistry past paper, October-November 2020, paper 21 or paper 2-1. And we are on the last question, question 4. There are 3 other lessons previously to this paper discussing question 1, 2, and 3. And we will now finish the last question in this lesson. Okay, iodine is used in many inorganic and organic reactions. State and explain the trend in volatility of the halogens from chlorine to iodine. That shouldn't be too difficult. The volatility decreases down the group. As we know, fluorine and chlorine are gaseous at room temperature. Bromine is a liquid and iodine is a solid. Volatility describes the tendency of a liquid to evaporate and become a gas. So how easily the substance get into the gaseous state. So that is one point. We stated volatility decreases down the group, and now we need to explain why is that. The reason is that we have more electrons in the atoms when we go down the group, which means that there are more or stronger, greater intermolecular forces between the atoms, which reduces the volatility. Greater molecular forces between the molecules. Explain why Hi is the least thermally stable of HCl, HBr, and Hi. The reason for that is because Hi has the lowest bond enthalpy, has the most shells, and that means hydrogen and iodine are more easily separated than the others. The table shows the electronegativity values for hydrogen, fluorine, and iodine. Explain in terms of intermolecular forces why Hi has a lower boiling point than HF. So again, this is about the intermolecular forces, and the reason here is that if we look at the difference in electronegativity between H and F, it is 1.9, whereas between H and I it's only 0.4. That means that HF has permanent dipole forces, whereas HI has only induced dipole forces. And from that we can conclude that the intermolecular forces in HI are weaker than in HF, which means lower boiling point. Iodine reacts with hot concentrated aqueous sodium hydroxide in the same way as chlorine. Write an equation for the reaction of iodine and hot aqueous sodium hydroxide. I2 plus NaOH and reacts in the same way as chlorine. And yeah, this is a reaction that we need to remember for A-level. This is the reaction of chlorine with hot alkali at around 70 degrees Celsius. And when chlorine reacts with hot sodium hydroxide, we get sodium chloride and we get NaClO3 and water. That is the balanced equation, so we need to replace the chlorine with the iodine. And that's the balanced equation. Right, for B, iodoalkanes contain carbon-iodine bonds. The simplest iodoalkane is CH3I, iodomethane, and that can be made by from methanol and we need to identify the reagent that can convert methanol into iodomethane. We have different options here. Easiest is probably just HI, but there are other options. PI3, for example, or phosphorus in the presence of iodine. One,2 diiodoethane, CH2I can be made by bubbling ethene into liquid iodine. Fully name the type of mechanism shown in this reaction. That is electrophilic. Addition. We have carbon-carbon double bond, which means we have a negative charge center around the double bond, and the iodine. Coming closer, we'll experience an induced dipole, becoming positive on one side, negative on the other side, and due to the negative charge center here, we have the electrophile that will attack right here. J reacts with NaOH, forming different products depending on the conditions used. Name J. Alright, longest carbon chain. So let's copy that quickly. 1, 2, 3. I goes here, and here we have another group. Longest chain, 1, 2, 3, 4. So we have two groups on the second carbon, which means we have 2 iodo, 2 methyl. Butane, again longest carbon chain, 1, 2, 3, 4, which means we have butane, no double bonds or anything. This lone line here means we have another CH3 group down here, which is a methyl group. UPAC naming the halogeno group comes first. Fully name the mechanism of the reaction of J with sodium hydroxide to form K. This is, in this case, not an addition, but a nucleophilic substitution. So why is that? Let's go over that quickly. So what happens here is that from the sodium hydroxide we basically take the OH minus ion, which is a nucleophile, and it will attack this carbon right here, and the iodine goes out. Nucleophilic substitution again, because the OH group replaces the iodine. J reacts with sodium hydroxide dissolved in ethanol to form a mixture of two alkenes, L and M. Alkene L is shown. Which one is alkene M? So we have two options here, and the double bond can either go to that side here or to that side. So the other option is the double bond here. So these are the two isomers. In the box provided, okay, we did that. Explain why L does not show geometrical cis-trans isomerism. And the reason for that is because it has two methyl groups attached to one end of the carbon-carbon double bond, specifically here and here. Cis-trans isomerism. Quick example. Like this. We have maybe H here, Br here, Br here, H here. So we can have it this form or like this, where this is our trans isomer. The groups are opposite sides, transferred, and here we have the cis isomer on the same side. L reacts with hot concentrated acidified potassium manganese oxide to form propanone and one other organic product. Identify the other organic product. There's L is here. Propanone and the other product. That should be the oleic acid. Propanone reacts with excess alkaline aqueous iodine. Complete and balance the equation for this reaction. So you can try that on your own. You can pause the video and try to balance this equation. The answer will come now. So we have 3 iodine, 4 hydroxide ions. This is fine. 3 waters, 3 iodides, and the additional product is CHI3. State 1 observation that can be made in this reaction. There will be a yellow precipitate. Alright, that's it for paper 2, October-November 2020, paper 2.1. I hope to see you for the next paper for bio or chemistry. And if you like these videos, if they help you to prepare for your A or AS levels, please consider subscribing to our YouTube channel so we can reach more people that want to prepare for their exams. Until then, have a good day and see you next time.